Again, Anupam.
Yeah, so LLMs are all there in the deep learning side of it. Analytics is a separate branch altogether. And again, as I said, you mentioned initially that it forms a bigger structure of it.
Okay.
Major confusion is always there will be a gray area in terms of what is where. So between neural networks, etc. When we go deep, then we try to understand that's more towards how do we look at data, how do we process data. That's where we come. So yeah, that's
Okay.
what my
Great. Anything else, Poonam, you would like to add? Top two things so far.
Or by with the help of human intervention that can be categorized as them, and the other things can be categorized which are not learning but have an intelligence like the human actions can be.
Okay. Om, you want to say something?
So AI is a broader concept. Under this umbrella, we have machine learning, we have deep learning, we have data analytics and business intelligence. So under machine learning, we are asked to input the data from which the machine learns the patterns and it learns from the data and gives you the expected output. So this is mainly used when the requirement is smaller and the data size is smaller. And when we use deep learning and LLMs, it requires huge investment and also computation. So whenever there is a large set of data and the expectation is high, we use large language model or deep learning. And when it comes to the data analytics and data intelligence, it is surface layer where user would like to see the data in the form of dashboard.
Sure. Sachin, anything else?
I think pretty much it's covered already.
Covered? Okay.
And I had a quick question.
Hmm.
So when it comes to missiles, right, you fixate a target
Hmm.
and then to go to that, even if there is variation, right? Would you call that AI?
Yeah, 100%. Why not? Yeah. They're all, I mean, being driven by, certain training, right? It has gone through. So there is an object detection happening. Computers are processing. There is a wall in front of you. They have to change their height, do certain things. So it's all robotics and coming in here. ML? AI is used. I don't know for sure ML is used or not. Again, go back to the same thing. Which one? No, because ML is the baby of AI. So the moment you say ML, AI is automatically covered. So that's what I'm saying. AI and dollar use without failure. Right. So AI is there. I mean, so like, defense is also saying, we are getting more into the AI and all of those things, right? So what form of AI, that will be, their own secret. I mean, they will not tell whether I've used a reinforcement learning or like, any sort of things coming in. Yeah.
So how do we differentiate the intelligence and automation? Like
Automation is in AI only. That is also AI only. Yeah. I mean, nobody uses automation now, right? So, I mean, even if you want to sound intelligent, you'll not say I've automated this, right? So you'll say I've used AI to automate this, right?
so this one. So, I want to build an application where I use AI models, like, which takes prompts and then translates into 3D printing designs and all the requirements that it has.
Yes, yeah.
And then it gives an automatic this one.
Yep.
So I can still consider it as AI or
Use that. Like, everybody is like, I mean, most of you are working. Start using AI in your word. Like, I mean, in your vocabulary, right? Everything that you're working on, throw in AI, right? I mean, just don't make up things. I mean, if you've written a code, don't say AI, right? I mean, you can say I have used AI to generate the code, right? Or I have done like, efficiency gain in the coding and all of that, right? But start using AI and dollars more and more. There is no right time that after you graduate, then I'll start to use the AI. Start using it now. You don't even need a degree to be, becoming good in AI. Things have moved so far along that you don't have to wait for a formal degree to say that you are AI educated. You are automatically AI educated. You just need to find the right areas to apply AI and showcase the benefits in dollar terms or rupees terms. Yeah.
And I think in addition to this, we will have to learn whatever the subject or the application we will
Yes.
apply this AI.
That's where your domain expertise comes in, right? So let's say you're in defense area or somebody is in automobile, right? Your knowledge will be more about the proprietary knowledge that you come along with, right? So your interpersonal skills, your communication skills, right? Your people related things, right? I mean, AI really cannot replace that, right? That's what you have as your thing, right? So then you have to combine that with the AI to create more tangible and intangible, gains to the company. Yeah. Santosh, you had a question?
Yes, sir. Few things we learned, like one thing was the diagram, that was very confusing diagram. You go to any forum also with that AI email.
That's right.
So
That's
you
right.
explained and the examples were very good. So now I can answer somebody
Mhm.
in a better way. The second thing was about the synthetic data,
Hmm.
which I was not aware. I mean, we had in past, like I was telling, Arpan, that we had a performance testing tool called Loader.
Mhm.
We generate dynamic users, right?
Yep. Yep.
That's a synthetic data. And the third thing was the graph, where you said that deep learning and machine learning, when to use what? So in my knowledge, and always the term said deep learning, right?
Hmm.
So we think that it is like more depth of code.
Hmm.
That is the way I was thinking.
That's right.
It is a different layer of data actually.
That's right. Yeah.
It's like a more data you train to the algorithm. So that was actually clear.
And different technique as well.
Yes.
So neural networks. So yeah. So when you have a deep, so the reason why it's called the deep, there are many, many layers of neural networks. So 1 layer, 2 layer, 3 layer, 4 layer, and you'll get to know more about the layers and what exactly it means, but it's like a deep network, right? Yeah.
So
Yeah.
I was not able to differentiate.
Right. Yeah.
Always I push to the wrong direction.
Yeah. Yeah.
So that is very clear. When to use ML, when to use deep learning.
Okay.
So there are
Awesome.
other things also, but these are main highlights for me.
Cool. Good summary. Any other questions, comments from anyone?
Sir, I have a question. When it comes to synthetic data,
Hmm.
so how far the model is going to give the proper result during optimization? Especially when it comes to medical domain or pharma domain. There are cases where you don't get to see the restricted data. So it may not be possible to mimic that field of data.
Hmm.
In the field of research, when somebody is inventing a new drug, so you may not be having complete data,
Hmm.
but to mimic or simulate the similar data,
Hmm.
it's very difficult.
It is difficult, but it's also a function of what you have as the starting data that you're giving for generation of the synthetic data, right? So let's say, I mean, I don't know much about the medical imaging and all of that, but let's say you're building an engine for detecting some sort of tumor, right? If you've already given it, let's say, thousands of images, which are publicly available from some repo out there, it will learn that behavior, right? So how does a tumor look like, right? Now you can say, okay, now create the images which only show 10% of the growth in the very early stages, right? So that image was not there with you. The AI is intelligent enough to figure out if I'm looking at this. So I have one where 70% is there, 60% is there, 50% is there. Now I can do like the extrapolation to figure out how would a beginning stage will look like, right?
Different variants.
So that is how you can really create. I'm just giving you some example without knowing too much about that domain, but that's how basically synthetic data is really built to replicate your true production data. Right? Any other questions, thoughts from anyone before I move on? All good? Okay, so then let's address this point. So when we're looking at the AI ML, I mean, these are the broad analytics that people will be doing, right? And again, I'm not looking at the generation part over here. So Gen AI is not being captured over here, but you'll be looking at either descriptive or diagnostic or predictive or prescriptive, right? Descriptive is what has happened. Diagnostic is why it has happened. Predictive is what will happen in the future. That's where the prediction really comes in. And prescriptive is what should you do for addressing a particular point of view or the business you use case, right? Descriptive, what has happened? Any examples anybody can think about the descriptive analytics? Or descriptive AI? I mean, let's not use the analytics term, let's use the AI, descriptive AI.
They stop building watches or not, sure, but they are in loss.
Hmm.
If we are having the customer data, lot of, they are having lot of data, like, uh, that data we are, seeing, and we are just analyzing that, what happened with this
Yes,
particular brand.
yes,
Seeing the, then we draw some graph.
Yep.
And based on the, for statistical analysis, all these things.
Yep.
And based on that, we decided, okay, this is a particular reason, maybe for this brand, customer likes so much, but they increase the price also so much for that particular brand. And the brand which customer did not like, they have reduced that and they try to advertise that particular brand more. So based on the pattern or this graph, we decided that, okay, loss is because of this. This was the fault. That will be this descriptive analysis and diagnosis analysis. All that.
Yes, why? The why part, yeah.
Both, maybe both will come under descriptive statistics.
Okay, good. Anybody else, any point of view? So simple example, let's say again, going back to the stocks that some of you are investing in, right? So when you look into the historical pattern of the stock, what has a stock price done in the last 6 months, 1 year, 1 quarter? You're doing nothing but describing things. You're looking at the historical data, right? What is the last 6 months stock price trend? You're plotting that, you're dissecting it, you're trying to see how many red candles, green candles we have. That's nothing but your descriptive analytics. When you say why it has done that, why did the stock price go down in last 6 months? You're looking at diagnostics, right? So why, answering the why question. Now, why could the stock price go down? The revenues did not come in, or the revenues were coming in, but the profitability was not there, right? Or they were both there, but the competition was doing really so well that, I mean, even though this company was growing, but somebody else was growing like, 10x or 100x of those things, right? Hmm? Yeah, so publicity, negative branding, all of those things, right? So all of those things are there. So that is why it has happened, right? Then comes the predictive part. What will happen in the future? What may happen in the future, right? So you're trying to do a prediction out there in the future. So you can say, given that the stock has come down 10% in last 1 year, my prediction or the forecast for the stock says it will be either going down by another 5%, or it will remain zero, or it will go up 10%, right? So you're making the prediction about this, right? So what will happen in the future? That's the predictive analytics, right? And the finally, once you've done the predictive analytics, then you're doing the prescription, or you're prescribing a solution to your stakeholders. So let's say you are the broker, right? Or you are the advisor, personal advisor, I mean, SEBI advisor, SEBI approved advisor. Now you're prescribing to your client base, go ahead and buy this stock, right? Because my data suggests that this is gonna go higher. All the fundamentals are in place. All the technical analysis is suggesting a robust turnaround. Please go ahead and invest, right? Now you completed the entire loop of the AI, right? So you began with what has happened, why it has happened, what will happen, and what should we do to really capture that trend, right? So this is the complete loop of an AI thing, right? And Gen AI cuts across different things over here, right? So now you can deploy the Gen AI also to say, okay, describe what has happened, create the charts for me, right? Yeah. Why?
Should have happened in the past, then that's where you are defining each and everything.
It's a loop.
It's a loop, exactly.
It's a loop.
So it should be the first, where we prescribe, then we describe.
Not necessary.
necessary.
So imagine, let's say, let's take a very, very simple example. Let's say you wake up one morning and you are experiencing, God forbid, some high fever, 102 degree Fahrenheit fever, right? So what has happened? You're running the fever. Now you come to the part why it has happened, right? diagnostic analysis. So you go to a doctor, don't become your own doctor, right? So you go to doctor, they will ask, did you eat something? Did you catch a cold, or, a number of different things. Are you running any infections and stuff like that? So they're trying to do the diagnostic analytics on that, right? Now they will come to the part predictive analytics. So if it is a viral infection, they will say, I'm not going to give you any antibiotics, right? So because it's going to grow by itself and all of those things. So that's the prescriptive analytics. Versus if it is, something which is a bacterial infection, based on that, then they'll say, okay, if I don't treat it, it's going to infect more and more, and it's going to go really bad from here. So I must do some prescription on that, right?
Prescription means that it's the result of all of
What shall I do about this? So what? What do I do with this, right? So do I need to take any actions? Do I leave it alone? How bad it is going to become, how good it will become, all of those things. And then how do I really position myself for those? Yeah. So that's the entire cycle. Which one is the most exciting to you?
Why?
Why? Okay. Anybody else? What do you think is the most important for the business? Predictive. Okay. How many for the predictive? Raise your hand. Both meaning? It depends. So I spoke about the AI and the dollar, and the other thing that you have to do very frequently, it depends. Right? So it depends on the situation that you're looking at, right? So there is no fixed answer per se. So everything is important, right? So if I'm the business intelligence team, for me, I really don't care about the predictive and the prescriptive. You do what you want to do with this data. For me, the job is to really tell you what exactly is happening in my portfolio and do a beautiful job in doing that, right? So if all I'm doing is I'm a Tableau developer, there's no extra dollars I'm going to earn by saying, you should go do this, because there is a team which will be focusing on that, right? I mean, what should we do with this data, right? My job, my focus is to tell a very good story, right? So and this is where, you can see, some of the companies, will have a metric, right? So let's say my metric is the defects per million units, right? That I'm shipping out. How many defects are there, right? This itself can be done by a descriptive analytics. So break down the defects. So what type of defects, doing a Pareto of the defects, right? Then let's say this is defect category 1, 2, 3. Then what is driving the defect category 1? Do breakup of this, right? And then do why this is trending, how it looked quarter over quarter, year over year. So you have very good end-to-end runway for doing a very solid job in the descriptive analytics and the diagnostic analytics, right? There's tons of dollars people are paying for this work as well, right? And that's where tools like Tableau, for example, come in, right? And Power BI. There is open tools, open source like a superset from Apache, right? All of those are focusing on this quadrant, which is, I'm just telling you what has happened and also why it has happened. This is where you will be looking into the predictive part, that, okay, let me take all of this data, historical data, and do the prediction for you, right? Which is, you have many other tools. You have, the library that we're going to look into, sklearn, for example, come in, right? You have Databricks type of players who are doing that. Even Tableau might be doing, some bit of this as well, right? So all of those is coming in. And then this is where you can now use more and more Gen AI to create the commentary, right? And you're already seeing that. I feed in my mutual fund portfolio and it will create a great summary, right? No human is looking into this, right? So like the Gen AI is creating the summary that in the last 6 months, these are the funds which have done well. These are the funds which are below the benchmark, and this is what you should be doing. I recommend you to get more invested in the gold and silver because it has given 70%, 130% return last 1 year. How many of you bought the gold at the beginning of 2025? So phenomenal returns, right? So like all of those things are prescriptive analytics, right? Which will come in from, given the situation that we are in, given the macroeconomic factors we are in, what will make sense. But this is only a probability. Anything that you want to do the prediction on, there is a probability associated with this. If you ever find an AI model which is 100% accurate, you have something wrong with that model, right? That is not right. Ever in your life, if you see 100% accuracy, 100% precision, zero error in your model, go back to drawing board. That is too good to be true. You should not rely on any of those models, right? Or they will only be good for a certain use cases. They will not be able to generalize for the other use cases as well, right? So it's ultimately it's a game of probability and chance. All AI models are wrong. All AI models are wrong, but some of them are useful. So that is the mental model that you should be having. So you should never rely on AI 100%, right? So even ChatGPT and like, Google will say AI responses may be wrong. Please validate the information, right? Because they are wrong. They suffer from hallucination. They suffer from self-learning. They suffer from many, many different things. So that's what you have to be really aware of, right? So we're not building a perfect AI system. We're going to build a useful AI system, right? Shall we move on? And these are some of the use cases across the different industries. This is all traditional AI ML, but I'll just zoom in and we'll be doing some of them as we go into the case studies as well. How do I go? There you go. So these are some of the things. So for example, in the retail, we do shelf space optimization, product pricing, product bundling, promotion, upsell, cross-sell. Banking, I have done the risk and fraud modeling in the BFSI for almost for a decade. So very, very important for you to have a very good prediction model. In the marketing sense, you have market basket analysis, market mix modeling, again, A/B testing or the design of experiment, right? So in the pharmaceutical world, you have again A/B testing, genetics analysis, epidemic forecasting, like a COVID, for example, how bad it's going to get, right? You have in the telecom customer churn analysis, customer acquisition or the cost of customer acquisition, CAC analysis, right? Product bundling, upsell, cross-sell, all of those things are part of being AI only. So, I mean, even before we looked into this Gen AI or this extreme AI obsession that we have developed in the last 3 to 4 years, AI was automatically there in everything that we were doing, right? So even before we knew about the Chat GPT or Gemini or Nano Banana or Nano this or Nano that, AI was already very, very deeply penetrated in all the work that we were doing, right? As AI professionals. So it's not new. It's everywhere that you can imagine, okay? Hypothesis testing will lead into your A/B testing. So what is a hypothesis, for example? Let's begin there.
If there is a if we are having one scenario that is called we call that is a null hypothesis, and on top of that we have
No, before you go to the null hypothesis, what is a hypothesis?
probability of assumption.
Possible explanation for something or an assumption that you have, right? So what could be some examples of hypothesis?
If
I'm doing good today, but how would you validate your hypothesis? Okay, so let's say I'm happy today, right? How would you validate that hypothesis? If you're happy, if you're smiling more, you're not feeling sad, you're not feeling depressed, then you confirm the hypothesis. Yes, you're right. You are indeed happy today, right? A hypothesis is a possible explanation or, something which will help you sort of look into a situation in a particular way. It cannot be true all the time. It can be true. It can be not true, right? So hypothesis, for example, let's say I can say my hypothesis, or let's say as a participant, my hypothesis is if I talk more in the class, I will get the module champion recognition, right? It's a very good hypothesis, right? So that's your null hypothesis, right? And let's say Rahul decides I'm going to challenge that hypothesis. I'll say I'm not going to talk at all. And I will prove the null hypothesis wrong, that without talking also I can be a module champion. That's an alternative hypothesis, right? Now, you don't have just two hypotheses all the time. You may have many, many different hypotheses. So these hypotheses become part of your A/B testing. So I have 5 different explanations for something to be happening, right? A, B, C, D, E. 5 different reasons I think something could be happening. I have to go validate all of them. How would I go validate all of them? I'll be running A/B testing, or what we technically call as a design of experimentation. You'll design your experiments. You'll go run those experiments. You'll validate those things, right? And then you'll confirm whether those hypotheses were correct or not. That's, like the A/B testing, very, very big one, right? What are the real examples of A/B testing? So they will say, okay, let me, sorry, social media campaign, right? So let's say 50% off or buy one, get one free. Which one is a better offer? Buy one, get one free, or 50% off? Both are same, but the audience will respond to it differently. You'll get 50% off, right? But there are a lot of people who will just say, okay, two products stuck together, let me buy them, right? Because at the price of one, I'm getting two items, right? That's a possible hypothesis. So you can say which one is going to generate higher sales, 50% off or buy one, get one free. And you run both of them, right? So for a certain product category, 50% off will work better. For other categories, buy one, get one will work better, right? You have to experiment, then you'll figure out. So let's say everyday consumable, you consume 2 packets of detergent in a month, right? Buy one, get one may not be a bad offer at all. You say buy one 60-inch TV, get another free, right? When you have space for only one, right? May not be a great deal. You'll say, boss, don't sell it for 1 lakh, give it to me for 50,000. I'll buy it, right? Or you say, spend 1 lakh and buy one TV, get one TV free, right? So it all depends on the experimentation. So, but that's the sort of thing where we do. Similarly, the website layout, shall it be this font, this layout, that should be the placement or something else. And Amazon does it, all the other players do it. I mean, they'll keep on changing certain look and feel, right? They'll start getting the data, where exactly is the more engagement coming in, where exactly the placement is working better, where is the call to action coming in, right? All of those things coming in. And then they will be able to decide based on that, what makes more. And then, of course, you have a metric associated with this, right? I mean, you cannot be operating the experiments in vacuum. So what is it that you're going to monitor? Right? And based on what those metrics are, you'll decide whether that makes sense or not, right? Is that clear? Any other examples of AI that you see happening in your day-to-day life? Netflix. What do you see Netflix doing? Recommendation. Okay.
What we see,
Hmm.
it will recommend these are
Sure. Absolutely.
Like,
Based on likes. But what if you don't like? I mean, I haven't given any thumbs up or thumbs down to any video so far in Netflix.
we have equal data it will have.
Right. Watch history, right? So if
Something has to be given to them.
that's right. So implicit and explicit behavior. So my explicit behavior will be give thumbs up. I really like the movie, right? But very few people do it. I give more thumbs down than thumbs up, right? I mean, that's a typical human behavior, right? Only when you're pissed, you will give certain rating, right? I mean, you'll not say, okay, 5-star rating, right? Just, like, I mean, the feedback is very, very biased from that point of view, right? But if I have watched the complete movie, or better yet, I have watched 2 times, right? That's the implicit feedback I'm giving, that, okay, I'm really loving this, right? So, okay, so fine. And they figure out, okay, what exactly was there as the ingredient of that movie? Was it about the particular theme, genre, actor, actresses, n number of different things? And they'll say, okay, probably you like this, right? And then they'll start servicing you more of the same, right? Any other examples of AI? Ads. Okay. YouTube ads, right? And then like I mean, whatever you've surfed on, they will start bubbling up some of those things. Yeah. Any other examples? Like which way? Yes, people have bought this, bought or looked into this, or frequently bought together. All of those things. Yeah, we'll be building some algorithms for those as well, right? So you see, I mean, it's pretty much everywhere that you can imagine, right? Shall I move on then, in interest of time? Okay, so these 2 notebooks I have shared with you folks, and this is like a quick recap of everything we have discussed. Nothing new. AI/ML, data science and visualization, a MISI based overview. MISI is mutually exclusive collectively exhaustive, right? So something which is not going to be common, and then in total we are looking at. So AI is the broad science of making machines smart, that is simulating the human intelligence, enable machines to mimic cognitive functions like reasoning, learning, decision making, right? All of those is AI. And the subset of AI are machine learning, algorithms, robotics, expert systems, everything. Machine learning is a subset of AI where we're going to have supervised learning, unsupervised learning, and reinforcement learning. And I'll talk about this in a minute as well. And there are many, many different tools and techniques we're going to use for doing that. Some examples: fraud detection, email. I think you mentioned, Santosh, you did something in the ham and spam recommendation system, right? Deep learning, now you know, is a subset of machine learning. A subset of machine learning where we use artificial neural network, not the human neural networks, ANN, especially deep neural networks. And there are examples like CNN, RNN, transformers. And these transformers are the brains for the LLMs, right? And then we have tools like a TensorFlow, PyTorch, Keras. We can do facial recognition, language translation, autonomous vehicle, so on and so forth, right? Data science is an interdisciplinary field. If you remember those Venn diagrams, it's cutting across the different things where you bring in your domain expertise, your programming skills, your statistics, the module before that, to extract the insights from your data. And that includes many, many different things, includes AI, includes some of the data engineering, includes your EDA or the diagnostic analysis. There are different tools for doing this. Data visualization is a subset of data science, and where you're going to do different things. So this is the big picture. Generative AI, all the generative AI, most of the generative AI algorithms have been trained using deep learning, right? So it's a subset of deep learning, which is a subset of machine learning, which is a subset of AI, right? Transformers, right? Yeah, I mean, most of them are transformers only, right? And I'll talk about how the generative AI engines have been trained once you understand the supervised and unsupervised as well, right? So these are that. I think that's one module. So this is how you can break up the AI, which is machine learning, expert system. Machine learning can be broken out into the deep learning, generative AI, and some of the other things. And I think same thing that we've done earlier. So I'll just skip this. Expert system is some of the things that were rule based. Like, you know, before the penetration of the machine learning and deep learning, most of the things were rule based. What are the rule based systems? Anyone? Huh? Calculator, or I mean, like, even you may have, like, you know, the scoring system as well. So for example, if somebody comes in and applies for a loan, I will look at their age. If the age is between 35 to 45, I will give them 10. If the age is above this, then I'll give them 8. If the age is less than 18, I'll give them a 0. If I know what their income is, I will give them 10. I will give them 8. And then you get the overall score. It's a rule-based system. That's the expert system, right? It was very popular in the 60s and the 70s, but then machine learning took over. People are still doing the rule-based, and there's nothing wrong with that, right? So, I mean, I can have rules, for example, right? So if you get 9 question correct, you'll get 90%. That's a rule. Like, there's no AI in an ML involved there, right? So yes,
In AI, agentic AI, all this.
right.
Is there any companies who are still hiring
For traditional,
only for statistics?
yes, absolutely, absolutely. You, just because the Gen AI has come in, it doesn't mean that those requirements are not there. What is coming in as the extra layer is that you'll be leveraging the Gen AI to fast track some of that development work, right? So for example, if you say that I'm great at doing all the coding myself, right? I may not hire you. If you say I can leverage the AI to do things faster. So the same model that would have taken me to build 15 days, now I can do in 2 days by leveraging Gen AI. Great, you're a great hire. I mean, nobody really wants to say, okay, go and write on a pen and paper and then come back. And because ultimately we're all after one thing. All the companies are after one thing, which we discussed earlier on, dollars, right? We really don't care how you get there, just do it, right? So leverage AI, leverage this, leverage that, whatever you want to do. I mean, only in academics we say do it by the pen and pencil and paper and all of those things, right? But the real word is like bring in whatever you want to bring in, get it done. As long as that is within the guardrails that you have to follow. So let's say if I'm looking at a very, very compliant industry, like a pharmaceutical or banking, right, or anything of that nature, where I really cannot trust some of these systems, right, for whatever reasons. I mean, even though I think there's no fear, but let's say those things are not there. Cannot use LLM to generate the code. There are a lot of companies which are still following that, right? So you cannot send your code to GitHub or Cursor or Windsurf or anything out there. Then you must follow what the company says. But if the company is open, by all means, leverage the GenAI, and you're still required. GenAI cannot do all of the things. But you plus GenAI will be so much better than you alone or GenAI alone. So you cannot live without each other, right? So you have to adopt it. And that's how you're going to be more efficient going on. Yeah. So now moving on, machine learning is broken out into two broad categories, supervised and unsupervised, right? Let's talk about that in a minute. Supervised is when you have, the main thing is labeled data, right? What do you mean by labeled data? When you say, I'm giving you all the inputs, X's, now we are getting in the technical details. That's what we're going to follow in some of the hands-on work. When you're giving all the X's as the inputs, and when you're saying, what is the output? And you have a label on the data. That's what we call as a supervised learning algorithm, right? I'm giving you all the inputs. I'm also telling you what are the outputs coming in, right? So what are the examples? Let's pick one example. So let's say the number of rooms, square feet of the apartment, right? Locality, age of the building, right? The builder name or the brand of the builder. These are all my inputs. These are all my X's, right? And using this, then I do the price of the house, price of the apartment. So I'm giving my model all these X's or the inputs, which is how many rooms it has, what is the square feet, what is the locality, age of the building, builder of the building, right? All of them are the inputs I'm giving my model. And then I'm also telling, by the way, this apartment is priced 2.2 crore, right? This apartment is priced 1.3 crore. This apartment is priced 70 lakhs. This is priced at 5 crore, right? I'm giving all of this to my model. And my model is learning the behavior, this as a Y, as a function of your X. These are all your X's. Learning the behavior of Y as a function of X is nothing but your supervised learning, right? When I'm providing the inputs, I'm providing the label, and I'm telling learn the behavior between the Y and X's. That is supervised learning. Is that clear, everybody? So simple thing, right? But a lot of people get confused. Now, supervised learning can be done using many different methods, depending on what you're looking at, right? So linear regression, decision tree, random forest, support vector machine, k-nearest neighbor, naive Bayes, neural network, all of those are supervised learning algorithms, right? And then we'll talk about how it's broken up into different things. So now let's talk about the regression and classification. There are two major parts of the supervised learning, regression and classification. So we all agreed that supervised learning is when you have Y present. Everybody agrees with me? You must have a Y, then you are on the path of the supervised learning. But your Y could be a continuous value or your Y could be a categorical value. What is an example of a continuous value? House price, salary, temperature, GDP, right? Many different things. All these are the car price, the house price, all of those are continuous values. So it can take any value within a certain range, even the decimal values also can be taken, right? So a floating point, continuous scale is the continuous. Whenever you're looking at my Y as a continuous, you're looking at regression supervised learning. When the y is continuous, that means it can take any value, any permitted value within a certain range, then it is a continuous and regression problem. Is that clear? When my y can take only certain values, like a spam or not spam, disease detected or not detected, happy, not happy, neutral, right? Likely to buy, not likely to buy, those categorical values, they are not a continuous values, those are categories of the values, right? You're looking at the classification problem. So supervised learning is broken down into two main categories, regression and classification. If your y happens to be continuous, you're immediately on the path of building a regression model. If you are on the path of doing a classification, that means you're looking at the categorical value. Now the same variable can be refactored into a continuous or categorical, right? So sales, for example, if I'm just predicting the sales in the dollar terms, is it a regression or classification? If I'm predicting sales as a dollar numbers, it is a regression problem because sales can be any number that we're looking at. But if I say my sales, I want to have high, medium, and low category. Let's say I build certain rule. That's a categorical problem. So same variable can be reformatted into a regression or a categorical problem or a classification problem, depending on the need of the business, right? So for example, my goal was not to know exactly the sales to the second decimal places. I wanted to see whether my sales is going to be higher than this quarter or lower than this quarter or at the same level. It's a categorical problem that you're looking at, right? So depending on the need of what your problem statement is, you'll be going down and building either a regression or a classification model. Is that clear, people? I will explain that later on, but they're all either regression or a classification problem. Yeah. But just as of now, understand that supervised learning mean I must have y. If my y is continuous, I go down the path of a regression modeling. If my y is a categorical, I go down the path of building a classification model. So let me ask you a question. How many cars a person will own? Is that a regression problem or categorical problem or a classification problem? How many cars? Cars cannot be a decimal number.
But it is a continuous.
But it is a continuous number. So it can be like 0, 1, 2, 3, 4, right? So you can still build a regression problem and you can round it off and say, okay, this model says that it's going to have 2.1 cars, but I'll say 2 cars, right? Or I can make it a discrete, right? 0, 1, 2, 3, 4, and I can refactor that into a classification problem.
The person can have reply on all people.
Still 2 cars, no, not 2.1 cars, for example. So like how many kids a family is going to have? 0, 1, 2, 3, 4, 5, not 2.3 or 1.9, right? So that is a regression problem typically, where you're looking at the fractional things coming in. When you're looking at the discrete or categorical things coming in, that's a classification problem. But it must have a y. If you haven't given the model to do this y as a function of x, if this is not there, this is not a supervised learning.
All right.
Why is the output? There are many other names I'm going to talk about that. So why is the output? Why is the dependent variable? Why is the ground truth? Why is many different things depending on the context? What we're going to use in typical machine learning sense will be y is a label and x is features. This is the lingo we're going to use, right? Features and label. If we have a label, we go down the path of supervised learning. If the label is continuous, we are looking at regression. If the label is discrete or categorical, we're looking at classification. If the label is not there, you're looking at the unsupervised learning algorithm, right? As simple as that. So let's continue.
How many cars person can have? That is English because we don't know a certain within certain range we can.
It can be done both ways. So for example, you can, so you're saying, like, it can be like 15 cars also a person has. But there is it's a double-edged sword. So like how you want to how you want to model a particular problem, that's tricky. And I will give you one example. Let's say I have, and it's a good thing, and that's a limitation of regression as well, right? Because it's unbounded. Regression is unbounded. What you're gonna do? I mean, when we talk about that, it can take a value in that scale. Any value is possible, right? So let's say I have built a model which says, and I built a model for Dubai, and I'm gonna apply. Sorry, I built a model for, let's say, Toronto, and I'm gonna apply that model for Dubai, right? So this model says the number of riders meaning bicycle rider on the road as a function of temperature, right? So what do you think will be the relationship in Toronto? The number of bikers or bicycle riders as a function of temperature. What do you think will be the relationship? As the temperature rises, there will be more people who are going out to ride the bike. Everybody sees that point? I mean, who would like to go in that minus 30 degrees Celsius temperature and say, okay, let me ride the bike, right? When it's pleasant, right? 15 degree, 20 degree, 25 degree, you'd like to go out there and do, right? So let's say this model works great. So it says, as the temperature rises, more number of riders will be on the road, right? This is a typical regression problem. I take that model and put that in Dubai now, right? Where the base temperature is 40 degrees Celsius, right? For example, as the temperature rises, so now it's hitting 51 degrees Celsius or 52 degrees Celsius, my model says more riders should be there on the road. And how come I'm not seeing that happening? Right? So that's the limitation in a regression problem because it's completely unbounded. So it can also say a person may have infinite number of cars or a person may have 100,000 cars, right? Who would have 100,000 cars? Maybe somebody out there has that. So you're better off flipping that and saying discrete. So you can say last category is 10 plus cars. You may have 10, you may have 11, you may have 10,000. I really don't care. As long as you have 10 plus cars, you are being covered in that category. That makes sense, right? So that's how you should be framing the problem, yeah? Huh. That's right. That limit doesn't come in the typical regression problem. So it's typically unbounded because of the nature of the equation that you're fitting in. What the regression problem is, and regression is many, many types of regression, but let's say linear regression we are trying to fit in. It says a straight line. As long as you keep on going this way, the line goes that way, right? That's the limitation of the model. So if it is not a linear regression, then you're right. Then it will be bounded, it will have some sense, but still that is a limitation versus more like a bounded problem. So you need to just be aware of where the model was built, where you are applying the model, which range the model can operate, which range the model cannot operate, right? So that's how basically it is. All models have limitations. So you cannot build a model for demographic A and apply to demographic Z, right? So the model has to, the data that is going in the model has to be a good replica of wherever you're going to apply that model. Same use cases, right? So you cannot build a model for prediction of the equities in Indian stock market and go and apply that in NASDAQ, for example, or apply that in Hang Seng in Hong Kong, right? That wouldn't work. It has to be driven by your business reasons, and I'll talk about that in a minute. Like, your modeling technique is a function of what exactly is your objective function, what you're trying to accomplish, right? So your modeling technique is not something that you will dictate. You will be educated from the business point of view. What exactly are we trying to really estimate over here, or what we're trying to predict, right? And that will feed into your modeling technique, not the vice versa. Yeah. Okay, so then there are other techniques. Unsupervised learning is basically when we do not have the labeled data and you're looking at the unlabeled data, right? So what is missing in this? Y is equal to fx. There is no y. You only have x, right? So that's where the unsupervised learning really comes in. And there are many, many different things. So for example, if you want to do the grouping, right? Or what we call in the statistical sense is clustering, customer segmentation, right? Or when you want to reduce the number of variables, like a dimension reduction, right? or when you want to do the product bundling or the recommendation, those are all the unsupervised learning algorithms. There is no labeled data, or the labeled data is not required. I mean, you may still have the labeled data, but you decide not to use it. That's the unsupervised learning. Yeah. Many examples over here. And these notebooks are with you, so you don't have to worry about that. And there's a reinforcement learning, which is very, very interesting field. There's a different module in it as well. And that basically is not following this. It doesn't really care about the X's and the Y's and all of that. So it follows a reward and punishment mechanism, right? To like, give you a brief idea about that reward or punishment mechanism. So you have to define a reward function, right? Like how you train a dog. You don't say, go look at past 5 years of data and then learn this behavior, right? So that is not gonna work, right? Or you say, okay, I'm not gonna tell you anything and learn on your own. That's completely unsupervised also, right? So you basically reward the right behavior, you punish the wrong behavior, right? That's right. Self-driving cars also follow the same thing. So that's a reinforcement learning. And there's a like different sort of like, overlaps, supervised, semi-supervised, semi-unsupervised, reinforcement supervised, transfer learning also. All of those things are there. So right now in LLMs, we follow, in terms of the learnings from the LLM point of view, there are two techniques which are very common, which is called the SFT and RFT. And we have already spoken about both of them. SFT is nothing but the supervised fine tuning, and RFT is nothing but the reinforcement fine tuning, right? So what do you think will be the difference between the SFT and the RFT? SFT will be asking for the why, right? Reinforcement will say, I don't really care about the why. So for example, if I give a certain prompt to the LLM and I'll say, this is the response you should be generating. So what is X, what is Y here? X is my, Y is my response and X is my prompt. So if I give you this prompt, this is the response I want to see, right? It's a supervised fine tuning algorithm, right? Reinforcement learning, I say, I really don't give you any prompt response pair. I will just tell you whether I like this response or not, right? So I'm going to give you thumbs up, thumbs down, thumbs up, thumbs down. It was okay, fine. Let me figure out what really you require from this. But it's all the same technique, same methodology that we have seen will be applicable in the LLMs as well, right? Here are some of the names of the things that you've spoken about. And it all depends on who you're talking to, but I'm going to stick with this nomenclature. Features and labels. What are features? Your X's. What is label? Your Y, right? It's also called input variables. What will be the corresponding term here for the Y? Output variables. Input, output, right? Independent variables. Why they are independent? Because they are not being driven by something else. And then what will be the corresponding term? Dependent variables, right? Predictors. And I need to add it over here. Predicted, right? Predictors do the prediction. So this is predicted. X values, Y values. And then of course we have seen the target variable. And then what will be the, you can say input variables also matches with the target and the output and all that. So there are different terms that people use that you can familiarize yourself. But that's the crux of it, right? And this diagram I'm just drawing from there. You can look into this. Machine learning is broken out into supervised, unsupervised, semi-supervised, reinforcement learning. Supervised learning can be broken out into regression and classification. Unsupervised learning can be broken out into multiple other categories depending on what you're trying to do. And semi-supervised and reinforcement learning are different, right? Where is deep learning here? And where is AI over here? Just to confuse people. Where is deep learning? Where is AI? Huh? The whole thing is AI. So everything that we do is AI only, right? So that you can never go wrong with that definition. It's all AI, right? It's all AI. Then where is deep learning? So you're saying this is deep learning? Okay. So all of these, everything that we're looking at over here can be a plain machine learning or can be a deep learning, right? So a supervised model can be a machine learning model or it could be a deep learning model. Unsupervised learning model can be a machine learning model or a deep learning model. And if it is a deep learning model, by very definition, it is a machine learning model also. Again, go back to that Venn diagram, which is AI as the mother of all, then ML, then deep learning. Within deep learning, then you have your generative AI, right? And then you're looking at this broad umbrella term, which is the AI ML, right? So you're still doing AI ML, you're still doing AI, but depending on whether you pick a simple model, it will be a machine learning supervised algorithm, right? Or if you pick a deep learning, machine learning, deep learning supervised regression model, right? So that's how basically the term will be, depending on what you're looking at, right? Or AI. So if you begin with, I am building an AI model, then I'm going building a machine learning model, then I'm building a deep learning model, then I'm building a supervised learning model, then I'm doing a regression problem. That's the hierarchy. Everybody gets that? So your regression model could be sitting in the supervised learning, as we've seen over here, but that supervised learning will be a deep learning, which is a subset of machine learning. Machine learning is a subset of AI.
So is it the data, the amount of data that differentiates machine learning and deep
Amount of data, amount of complexity also. So you may have a lot of data, but the problem is really simple, right? You don't need to build any AI or machine learning model for it. I mean, you can write an equation. So that's a good question. So if I can model using an equation, let's say if I'm building a sine curve, right? Something which follows a sine curve. Do I need an AI for doing this? No, I just need to say y is equal to sine of x. And that x could be hundreds of years of data. I really don't need to build any AI and ML for doing this, right? But if the curve follows this, and then it does this, and then it does, do some fancy stuff, right? That I need to predict. Then I really cannot fit a sine curve over here. So that's where the ML will come in. That's where you will see all these other branches of the ML coming in, right? So it depends on the complexity. Is that clear, people? GenAI uses mostly the unsupervised, supervised up to a certain extent, and a very heavy amount of reinforcement learning. So I'll talk about how a GenAI model has been trained from the beginning, but I mean, nobody really shares that. So what it does is basically it says, let's look into this. Sun rises in, what do you think will be the next thing? In east, right? That's all the GenAI models have been trained on, right? Which is fill in the blanks. So because of all the text that we have generated on the internet, it says whenever somebody says sun rises in, I'm 90% confident east will be the word which will be coming in. So it basically learns that behavior. Okay, what should be the next word that I should try to predict, right? Unsupervised learning. So it says, okay, east will be 90% of the time and west will be 10% of the time. So for example, somebody says, I know that sun doesn't rise in west, right? It's just stating the fact, right? So it's also being exposed to that sun doesn't rise, and it figures out the double negation and all of those things, right? All of those things, but it says, east is the most common word. So I will make that prediction that east will follow up this one, right? So it learns that behavior, which is what is going to be the next word, then next sentence, then next two sentences, then next paragraph, and then it basically does the entire writing for you. So now you can use that to write the entire thing, right? Based on the prompt. So if you say, write a poem on this, right? Or write an essay on cow, like, I mean, we used to do in the childhood days, right? So it has seen so many essays on cow, so many essays it has seen already. It knows like more than you about the cow, right? And it will write the entire thing because it has seen all of this information as being the training process, unsupervised training process. Then I can also say, when user gives you this prompt, please generate this response. That's a supervised, right? Or I can have a reward function, right? When you generate west, I will punish that, right? I'll say, no, west is not the right thing. You should say east. And it learns that behavior over a period of time. So all of those are, something which is a very, very different science altogether, right? So GenAI is not very different from what we're doing over here, right? So what is it that makes the GenAI very unique is this internet scale of data, right? This humongous data that nobody can store. And it has crawled websites, PDFs, Wikipedia, YouTube, Insta, Twitter, anything that you can name. It has basically gotten the data from all the places. So that's where a lot of people say, by the way, this is a privacy risk as well, right? Why? Because somebody's confident information may have been used for training the model, right? So all of those things are there. So you need to be careful, right? So there are litigations as well, for example, that, by the way, I mean, you've generated this poem, but I was the creator of this poem, right? Or you've generated this image. That was my image. I mean, why did you generate this image, right? I mean, I created that dog drinking thumbs up on the beach, right? How come your model is generating this? Because it has been trained on this data, right? So all of those things will come in. Is that clear? All good? So the GenAI is like the amount of the data. And then this data has to be running somewhere, being trained somewhere, all of those things. That is the amount of the compute and the hardware. So it's not very difficult for me to train a model. It's just difficult because for this compute, I must be spending $100 million plus, right? To train a model. And I need to have all the hardware, all the NVIDIA chips, all the GPUs, and all the time in the world. It may take months to really train the model, right? So that's where, when Chinese models started to come in, like a DeepSeek, right? They were able to do this at a fraction of a cost. Like, they'll say, okay, I trained this model on $1 million, right? Same amount of data, but because of the methodologies they've chosen, they are able to train on the less amount of things. So that's where basically this is, and that's what is fueling all the rush for the hardware stocks and all the things, and the output comes out, which is doing all sort of fantastic stuff, right? So that's where the AI engine is coming in. But this data is the secret sauce. This data is the secret sauce for any GenAI engine. So if you have some proprietary data which has not been exposed to the outside world, that's what your focus has to be, right? How do you tap into that data to really create a solution which cannot be copied by any of your competitors, right? Is that clear so far, people? All good? So now let's go into the last article, which I think I have shared the link with you, which is what is a typical modeling workflow or AI workflow. And then we will break for the lunch, and then we'll come back and then start doing some hands-on work post-lunch, yeah? I think this was good discussion and needed discussion so that you're clear on why we do certain things, what are the terms we should be using, all of those things, right? So this is a typical machine learning workflow, right? You need to be very clear about the business objective. What is it that we're trying to do, right? Clearly state the problem and its value to the business. So what could be some good business objectives, for example? Can anybody name some business objectives? Which will be good thing for your beginning of your machine learning project or AI project? Okay. Right. Energy reductions, all of those things, right? So you must define. So I want to earn $100 million extra revenue. Tell me, how do I get this revenue? How many extra? I want to increase my customer acquisition by 10%, right? Or I want to reduce my customer churn by 5%, right? Or I want to, do I don't know, let's say I want to grow my sales by 2x, right? I mean, it could be any number of different objectives. So you must define your business objective very clearly. Any real-time business objectives that people have done some AI work on in your day-to-day life in your own companies? Hmm?
We are developing a model can predict
Which can predict
diseases from X-ray or human these images.
disease.
Disease.
Okay.
Diseases are the size of the tumor from X-ray or CT scan.
Any other examples of your own? Yeah.
You build a smart keyboard. It connects to your database via MCP, reads the schema, then tells you this is the problem for Indian database. Blah, blah, blah.
Okay. Got it. Got it.
There is a tool which is there. on development, but there is already a tool which was developed by the company in terms of predicting what could be the problem which is there in the grid, or for that matter, let's say any specific application or any specific product, and how can we, if there is a, let's say, if there is a specific issue which is coming in, or the result has come down, this
Hmm.
is the actual situation, then what can be the possible outcome and how can we reduce it, what will be the maintenance thing, what will be the cost which will be coming in and when will it be coming in?
Yeah.
That is something.
Preventive maintenance. What equipment is gonna fail when,
Yeah, yeah.
and what shall we do about that? Yeah. Okay, good. So, but this is very important, folks, for your information that you must define the business problem very, very clearly. And it's not that easy. It's very easy to say define the business problem, right? But if you talk to your stakeholders, they will often talk about the symptoms and not the problems, right? Or the desired thing, but not exactly like, tell you in black and white what exactly is required. So that's where you have to be like, really going after them. And there are many techniques like, problem definition, asking them the 5 whys and stuff like that. All of those things are there to define your actual business problem and not the symptom, right? Symptoms are very different from the actual problem. So you must go after what is going on. So that's right. That's right. So for example, the business leader may come to you and say that my sales are going down. Help me fix it, right? If you go and do a sales modeling and come back with a fantastic answer or the sales modeling, maybe that is the right answer, may not be a right answer, right? So if you start with the wrong business problem, you will 100% guaranteed to get a wrong AI solution as well, right? So you should have asked like, okay, sales, we should do something about that sales. Why is it going down? And then you peel the onion layer by layer. And then you say, okay, sales is going down because of customer churn, right? Because I'm losing people. It's not going down because my pricing is bad. It's not going down because the competition is doing something. It is going down because I'm losing customers, right? Now that's a much more defined problem. That how do I really then go and work on the attrition prediction, right? And then use that to do a better job, right? And then after that, you do a data collection, data understanding. This is where things will break down. So either you don't have the data, or people don't want to share the data, or the data is there, but nobody knows where the data resides, or you have the same version of data in 5 different places and you don't know which data to rely on, right? Or data is so messy and like, accessing this data, they'll say this will require the approval from the CEO. CEO says this will require the approval from the board, and then you are going in the cycles, right? It's not getting the data as required. So having that data access and in a consumable format is going to be really important, right? I will not talk about this over here. I will not talk about this over here because that depends on, how you have to do certain things. So we'll assume you have defined your business problem. You know what ML technique is going to come in because of that business problem. You already have collected the data. You have understood what that data is. You have the domain expertise. We'll begin our journey over here, which is the data pre-processing. Assuming data is ready in a CSV, in a JSON, in a SQL database, somewhere the data is ready for you. How do we clean, transform, and create new features and then go forward, right? And then model selection, which model we should be selecting, building the model, training the model, prediction of the model, evaluating the model performance, and then deployment also is something that we will be not touching in this module because we're not building that thing, and then you need to have some sort of cloud access and the thing. So we will be focusing more on these things. I mean, even data understanding will be focusing on, which is, how do we take this data, pre-process, build the right model, evaluate the right model, and then depending on the need, we can do the deployment. Maybe we can talk a little bit about, some of the methodologies like a pickle. You can create the model object, you can call the model object, but not the hosting of the models and stuff like that, right? So from here on, once you're back from the lunch break, we will begin directly over here. And this is very, very interesting and good process that we should be going through in terms of building it better. Is that clear? Sounds good. Data collection, no. I believe you have already done some of the work, no? In terms of the yes. And it's a very, very nuanced thing. I mean, it may be like, subject to the particular organization, subject to a particular use case. Like, let's say I want to do something in the social media, right? So then I have to go and see where exactly can the social media data, right? So you need to prepare the data. So you need to figure out No, we will assume you have the sources to connect to your data. I believe you have done some other modules in between or no, like the data access and stuff like data collection you haven't done. Okay, so we'll see, how much we can talk about that, but I'm going to focus more on the core concepts of the modeling, evaluation, and then if time is left, we'll think about, because the modeling techniques are also like so many that you have to go through, right? It is, yeah, it is data pipelining, and then having the all the data flow in is you're right. I mean, it is part of the data engineer, but nowadays, I mean, there's a lot of AI engineers also, for example, they are doing things end to end, right? So then you might be required to understand whether my data is sitting in a no SQL database or SQL database or some other places. How do I fetch that data in? All of those things will be coming in. But I'll not be focusing too much there, is what I'm trying to say in this model. With that, let's break for lunch. Folks online, we are heading out for the lunch for 1 hour. We'll be back by 2 p.m. and we'll begin our activity from there. Thank you.
So you know, I'm running in